inverse zero. Cosine is zero.
Negative sign.
Wait, cosine.
Is it? Wait, what? It's just plus or minus 1 7.
Sine. Cosine. Negative sine. It's supposed to be maximized. Oh, it's
No.
zero.
It maximizes to 0. So it's
No, so it's 1.
maximizes to 0.
You missed 1
So from 0 to 1, yeah.
I missed the whole week. It is. I missed this.
So your
I'm
error is
so
plus or
sorry,
minus
Bertie. I would
1 7.
I'm not sorry. This is funny. I'm laughing at you.
1 by 6 factorial, right?
1 7.
Wait, what?
Sin of 0 is
Okay,
0.
so maximize the 1.
Yeah.
No, it maximizes at 1, so the value is 0. No, but okay, but at 0, so it maximizes at 0. So that's what the decimal was. It maximizes at 0. Sine is all the y values, right? So maximize 0 is 1.
Wait, how do we know
Y
this
value is
maximizes
1.
to 0? What? Oh, the y value.
Yes.
Oh, that's 6. You
It's
found
a
that
6
stuff.
derivative.
That's the drawing.
The sine of 0 at 1. Maximize.
The sine of
Why would you have
0,
7?
0 x value.
Isn't it n plus 1?
Yeah.
So
And
would
so,
it be
yeah,
For
because,
sine?
yeah,
I was telling you it was 5. I don't know
the
what you
sine of 0.
I'm sorry.
Sine of 0.
Left you.
Cosine of 0 is 1. Yeah. You know, look, imagine the unit circle. Look at it. So it's maximized out. What is it? Not 1, but pi over 2.
Yeah, but it's real.
It's
But it's
Pi over 2.
Well, maybe that's what he's
Yeah.
I'm guessing Taylor's theorem is another way to
So it is 1.
So I
It has to be, yeah, it's just another way.
You said it was 1 7.
She told me 1 7.
No, you're the one who said
Yeah,
it.
but then
It's still 0 though.
she confirmed it was 1 7.
Wait, we don't.
0 to 1.
Isn't it cosine x? Wait,
You can do pi over 2.
No, every odd will be cosine, right? Won't every even be back to sine?
start.
Yeah, cosine. Cosine, then negative sine, then negative cosine, then positive sine, then positive cosine, then negative sine, right? I think so. Guys, how do you maximize? How do you maximize negative sine on 0 to 1?
Well, it would normally be.
It would be at 1.
I think it would be 0. Maybe it was negative 1.
But sine of 0 is 0.
So it would be 0.
And remember, aren't we trying to technically maximize the absolute value? Right? So we're trying to get the highest value that it could be.
Oh, so there's, absolutely.
Well, hold on. Wait. Technically, is sine 0 to 1?
Oh, pi over 2?
Isn't it 1 at pi over 2, which is a little bit more than 1? Remember the paragraph I had you read that said important. It said, are we going to use sine of 1? No, we don't know what sine of 1 is. It's some nasty decimal. So use the nearest reasonable rational number. So don't use sine of 1 because the whole point is we don't know what it is. Use, okay, well, sine is maximized at. Remember, guess a little bit above, greater than, so use 1. No. Pi over 2 would be the z. We just want the maximum value of. We don't really even need to find the z. I mean, the z would be pi over 2, but the point is, what's the maximum value of the sixth derivative? 1. So therefore, we can go ahead and plug in and say, okay, 1 over 6 factorial times, why did I plug in 1? Why isn't it x minus 0?
Because it's 1 minus 2.
Because I'm plugging in 1, right? X is equal to 1. Caroline. Make up a what? No. Because I don't want to, okay. I just said that I'm going to choose basically z to be pi over 2. But the reason I'm choosing z to be pi over 2, first of all, I didn't really even need to think about who z is. Second of all, I was supposed to think about the interval 0 to 1, but sine isn't even all the way up to 1 at 1. At 1, it's a little bit below. So it's like, okay, well, what is sine there? I don't know, some nasty decimal. It's not pi over 3, pi over 6, pi over 4. Even if it was, who knows what that is. So I'm not even using 1. I'm going to say, well, pretty soon thereafter, I know that sine is bounded by positive 1. So I'm like, okay, cool, let's use the positive 1 value. Now, technically, that does happen at pi over 2, but once again, the whole point is, what am I going to plug in for the sixth derivative of f when it's maximized? 1. But I wouldn't choose 2 or 3 or 4 or 5, even though it would technically be true, because that's just kind of making the worst case scenario worse than it has to be, I guess. Making it, it's just not applicable. I'll say it that way. But I also don't want to choose something like 1/2, because sine of 1 could very well be above 1/2, and all of a sudden my worst case might now be inaccurate because I narrowed it too much. Does that make sense, kind of? Okay. So then the maximum error for your approximation, 3 decimal places. Oh, struggle. That's 1 over 720, which I'm sure some of you guys have already plugged into your calculator. One what? Okay. Technically, 0.001 would be sufficient, but no, it technically doesn't mean sig fix. It does in other classes, but not ours. 3 decimal places would be 0.001, but you know me, I like putting little extra decimals in there. Use your answer, to find an interval. So what am I going to actually use? 0.001. No, sine of 1 is not 0. Sine of 0 is 0. Cosine of 0 is 1. Sine of pi? Maybe that's what you're thinking, 1 pi. So sine of 1, wait a minute. I need to get sine of 1 by itself. Isn't this error? How do I set up an expression for error? No. It says use your answer to A, which is the Lagrange error bound. Don't go using alternating. Which, does it end up being alternating? Alternating would be the next term. The next term would technically be the 7th, right? Okay. The 6th is going to be bigger than, worst case scenario. Okay, that's fine. Alternating series, since it is alternating, I could go to the 7th term, but Lagrange says whatever, this one for sure. But hold on, do I need to plug this guy in? Okay. So I'd have sine of 1 minus, we could go through and make that guy 6 and make that guy 120 and then make that guy, what do we end up with, guys? 0.842.
You have to combine all of them or just all 3 of them?
Mm-hmm.
But when I did that, I definitely did get them.
Well, that'd be 120 minus 20, which would be 100 plus 1, 101 over 120. Which, couldn't we be super snazzy if we wanted to and actually just plug in the decimals and have it precisely? Yes, but whatever. I'm going to do 101 over 120, just because I don't necessarily want you guys rounding before you go subtracting in any problem on the AP, right? Okay, as I'm going up to the range, go ahead. Eileen, that was your question, right? The next term, which we say n plus first, but it would be the next term in the series. Right. It goes, when you add 0.001 plus that fraction, positive 0.001 plus that fraction, what do you get? What's on the other side? Does that make sense? Yeah. Use plus or minus 0.001, but the answer is not plus or minus. Oh, 2 or 1? Did you round or did you not round the fraction? Uh-oh, did you guys round? This is finding the sum that approximates sine of 1. And this is showing a range that's going to fall in between. actual, minus the approximate is giving us the error. So the 0.001 is how far off it could be. The range shows us where the actual is going to fall in between. Hey guys, I have a new mic. I don't want to yell. If one person starts whispering and another person starts whispering, another person starts whispering, then you guys all start competing and then it just whoosh. And I'm talking to a kid right here and we can't hear each other. So shush. So this one is saying how far off my approximation might be from the actual. This is saying the actual falls within this range. Which is also error. It's just another way of estimating the error. Lagrange is a worst case scenario, which will sometimes be the same as the alternating series error bound, but sometimes it'll be a little bit worse in the sense of it'll be a little bit broader. Because it's found a different way, and Lagrange works for any series. Alternating only works for alternating. So for alternating, we can get a little bit more precise. Does that make sense? Sometimes more precise and sometimes the exact same amount, but Jonathan. That's a good question. I don't have my calculator. It should have been from using the negative 0.001 plus the 101 over 120. If it was found precisely. Some of you guys might have rounded, so.
So is it kind of like there's like you just didn't write it in? On the other side of the sign, there's a less than or equal to?
Because absolute value, remember, absolute value means it's sandwiched in between this range, so it could be that much above or that much below.
But so like on the other side
Would be a negative 0.001. So you could rewrite this, which we did with the alternating series bound quite a bit, which is why I stopped writing it. But, sorry. You could take out the absolute value bars and say, okay, if the magnitude is going to be 0.001, it could be 0.001 above, or it could be 0.001 below. And then you add this to both sides. Okay. What about letter C? There's no way. Hold on, pause. Let's finish the thought. Letter C, why is it no? Perfect. It's not within the bounds of my Lagrange, aka my worst case scenario. Okay, as I'm going to write that, go ahead, Kyle. What's your question? Is that okay? Okay. Since 0.9 is not within okay, Gabby. You're good? Okay. Whew. Do we see once again why I had you guys read that paragraph one day and then read it again another day and we keep on referring back to it? Okay. Because if we did go using sign of 1, we'd be using the exact value that we don't even know. So that's not going to necessarily be helpful. Okay. In your notes, because some of you guys might have needed, which I'm not sure if you actually did, with a color pen to correct some stuff. Maybe you got it all right the first time. But let's go ahead and get into our notes because we do have a bit more AP practice. Guys, technically, I do have this homework. Due Friday, but to be honest, you know what? We should be able to have it done tomorrow.
Yeah, Kyle.
So listen, I'm not going to do a spot check tomorrow, but I am going to go over homework questions tomorrow. Because that should be enough time for you guys to get into it, get stuck, and let me know what's going on. Sound good? Now, here's a dilemma. Here's a dilemma. How much more are we doing? I'm doing kind of a combined section of the very last 2 sections. So a test is coming, not right away, but it is coming, which means on Friday, well actually even tomorrow, I will be starting not new content, but a new section with 10.4, 10.5. So the more that you can do tonight, the better. Sound good? Okay. In homework, I'll peek at it. Oh, I don't have a book. In number 42, when you guys get there, just a quick hint. The n of the summation is different than the nth degree of the polynomial. Actually, Kyle, I can use this one, can't I, to explain? Kiddos, the 5th degree, hold on, The 5th degree Taylor polynomial is when x is being raised to the 5th power, true? But if we were to write this, for instance, in like a summation notation, wow, that's rough. Okay. With n equals 0 to infinity, I would go ahead and write this as x to the 2n plus 1 all over 2n plus 1 factorial. Now, guys, hold on. Here's a dilemma, and this is what you're going to face in number 42. If I was to express this series in a summation, I would be using, hey, when n is 0, the first term, plug in 0. The second term, plug in 1. But I'm getting 1, and I'm getting 3, and I'm getting 5. The n of the Taylor polynomial degree is different than the n of the summation. Does that make sense? So the struggle is, if I was trying to do, for instance, the error for this guy, you know how we looked at the 6th term, right? I wouldn't be using n equals 6. Because if I plugged in n equals 6, wouldn't I be getting up to the 13th power? I don't want the 13th power. I literally want the 6. Okay, so then here's the idea of, if you are doing the Lagrange error bound or even the alternating series error bound, you need to think about the degrees that are going on and think about the theorems and how they're talking about, okay, the terms that you have, this is your approximation, you're going one more. And so if you're going one more in the summation, don't just go using the n from the nth degree Taylor polynomial. Does that make sense? This n's different than that n. So don't just go taking, hey, 6 and plug it in, because you're going to get way off. Instead, figure out, okay, what n would I be plugging in order to be able to, or just expand the series and find the term and say, oh, there it is, let's use them. So that's what I wanted to say about number 42 as to where it could get tricky. N's are used in a lot of different ways. So just because there's an n in the nth degree Taylor polynomial does not mean it's the same exact n that should be used in the summation notation. Okay, let's do it all together. 4th degree Maclaurin polynomial. What do we got? I did approximate, right? Okay. 1 plus x plus. How can you remember, those of you guys that already have this memorized? Because definitely some don't, and that's totally okay. How do you remember e to the x? It's increasing. I mean, a lot of them increase. It's not alternating, unlike sine and cosine. But also, e to the x's derivatives will all be the same. So all I get to use is say, okay, all of them are the same, and e to the 0 is 1, so it really just have x over 1 factorial, x squared over 2 factorial. The derivatives don't change a thing. That's what's going on kind of here. What? What am I supposed to be approximating? To the? E to the 1. Here's another idea, kiddos. This is the 4th degree Maclaurin polynomial, so p sub 4, but that's different than how many terms there are, because technically it's the 5th term, right? So once again, the summation notation and the nth degree Maclaurin polynomial will be very different. I'll box that. But what are we doing for the Lagrange? I need the 5th derivative, right? Except the 5th derivative, it's e to the x. Who is the 5th derivative? I'm plugging in 1, so it's 1 to the 5th. The 5th derivative of x is just equal to e to the x. I'm trying to maximize, right, on what interval? Maclaurin centered at 0, and I'm approximating at 1. Does that make sense? When x equals 1. Because I'm approximating e, but e is e to the 1 when x is 1. Right?
Where does it say that e is 1?
No. Shh. If I'm approximating e using e to the x, I'm approximating e to the x when x is 1.
Where is it telling you to find it when x is 1? Why would you be plugging in e?
Because it's e to the 1. They could have asked me to approximate e squared or e to the 1.1 or e to the, but they just said approximate e, which is understood to be e to the 1. So I'm approximating using this guy. To get e, what will you plug in? 1.
Okay. So
Does that make sense? Right.
E isn't X.
No, they did. Oh, but they didn't explicitly say when x equals 1, approximate e to the 1, which is e. They didn't tell you that. They said approximate e. Instead of saying approximating ln of 1.1 or sine of 1, they said approximate e, which is of 1. Does that make sense? So that's why I plugged in 1 for my x, because 1 minus 0 to the 5th. And that's why I'm thinking about the interval from 0 to 1. Wait, e. E increases. So it's going to maximize at 1, but hold on, isn't e 2 point? So I can round to 3. Because the whole point is you're trying to approximate e. You don't want to use e to approximate e. What's the point, right? Don't use e to approximate e. Say, okay, well, that's going to be bounded by, oh, okay. Whew. The nearest reasonable rational, 2.71828, 3. So I go ahead and, I think, right? 40 doesn't go into 10. 40 goes into 100 2 times. 100 minus 80 is 20. 40 goes into 200 5 times. Because I'm not saying at 3, I'm saying e is going to be bound within 3 since e to the 1 is 2.71828. So instead of plugging in the 2.71828, which is the whole point of this problem, which is approximating who this guy is, I'm going to say, okay, fine, worst case scenario, it's definitely within 3. I wouldn't use 2 because it's too small. Always choose something greater. Okay.
So let's say if it maximizes that, if the value is like up higher, do you want to round up or down?
Don't go down. Go greater, so 4. Or 3.5. I mean, you could use a fraction. But yeah. Or 3.25, because 3.1415926. Could do 3.25. Yeah. A higher rational number. Because pi is not rational, right? Because it's, hey, March 14th, it's coming. But e's not, we'll figure out something, right? E's not rational either. Oh, man. A pizza pie factory, then I'll be on board. One factory makes them all. Be better to have you guys to bring pie-related objects that are edible and appropriate.
Why don't we have a towel?
Because it's in the summer. Good try. All right, coming back. One reason why we shouldn't use towel. Can't celebrate during the school year. So you have towel. Good point.
That's yesterday.
So it would be February 7th.
Oh, well, we missed it, but we could have celebrated E-Day.
It would have been.
We would have had to figure out what time, though. All right. And it's not 2.07, so does it really even count? Anyway. Okay.
It was 2018. What we can do 2.7?
Epic E-Day, and we missed it. How would we have celebrated? Just gone around being like, E. Ooh, we could make it a little piggy with the E. You guys know what I'm talking about?
Yes.
Little circle, little... Anyway, never mind.
Little circle, little
E.
little circle, bigger circle. Half circle, bigger circle. W, W, E, E, E.
Half circle, W, W, E, E, E. Have you guys never seen that? Why are we doing this in calculus? It's little circle, bigger circle, little circle, bigger circle.
Is half circle, then
Half
a bigger
circle. Oh, bigger circle, W, W, E, E, E. Oops. E. Anyway, struggle.
Only people work here, so they'd be super confused. I know.
Use your answer. Define an interval. E minus.
0.205.
That's this one?
That. No, that's point. That's there. Pretty much.
Wouldn't this be 2 plus 1/2 plus 1/6 plus 1 24th? Oh, thank you, thank you. That's weird. I don't know why I did that. Which would be 2 plus 0.5 plus, you guys know the decimal for 1/6, right? 0.166666. How about 24?
2.708. Oh no, not that bad.
What would 24 be? 0, 4? Yeah, 0.04. And that'd be 96, that'd be 40, 0. And that'd be 400. And that'd be... Oh, 1. Yeah, because it was 40. 1. That was, what was it, 6? Anyway, you guys could put all those together if you needed to. P.S. You know how to make a fraction into a decimal, right? Just keeps on reminding you just in case. Okay. Yeah. Yep. My bounds. And I showed it your way, so that way it was nice. Because it's absolute value, and I did a positive and a negative. So then E ends up being between 2.713. It says 3 decimals. Oh, we always do 3 decimals, right? Right? 8 and 5 is 13. Carry the 1. Oh. Yeah, carry the 1. No, I'm good. Oh, plus 2. So 3. Thank you, thank you. Then on the other side, 2 point. Yeah. 6, 8, 3. I don't know why that was so hard. Dun 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 dun. 2.71828. Hey, pretty good. Okay. Ready? Set. Let's go. Ooh. So AP-ish. Look at this. It didn't give us a function, but it gave us clues. Don't worry. The Endeavor card. Ooh, we need an Endeavor quiz before that test. Anyway, Endeavor card. Oh. You've got to know it. The special McLarens. It's very sad I said McLaren with a British accent. McLaren. McLaren. Huh? Who's French?
Yes.
What?
I have noticed that.
Oh.
And I was confused.
Wait, what did you say?
Oh, I know.
They have British accents, but instead of French.
How did you guys not notice? That's so funny.
The candle does.
Yeah, the only person.
Only the
Well, maybe they immigrated there.
The
That's a lot of
peasants.
immigrants.
Little town full of peasant people. Okay, so peasant, immigrant people. Okay, so come here. How do we make a polynomial? F of x is approximately, because it's a third degree Taylor polynomial. Don't we need f of, who's f of, yeah, there you go, plus times x. Oh, there you go. Did you get it? X minus 2, right? Because it's centered about, around, at. It can say it many different ways. The next one's going to be f double prime of 2 all over times to the power of. When do I know to stop? I have 3 terms. Nope, third degree. Okay, we good? Ooh, but we can't box it and be done. What do we got to do? Go find our... Now, we could say f of x is approximate, or we could say the third degree Taylor polynomial, right? is equal to? We could say f of x is approximate, or we could say the third degree Taylor polynomial is equal to, right? Because this, by its notation, is the approximate. F of 2 is equal to? F prime of 2 is equal to? F double prime of 2 is equal to? F triple prime is equal to? Is this alternating? Remember, long answer to the man. Which means you probably should have just left the factorials also. Anyway, Oz. A, the question goes on further, but B, bless you. Is this alternating? Just curious, real quick.
Yes.
Positive, positive, negative. Ah, okay. Just random, saying not alternating. But coming back, it does say 3 decimal places. Wait, what are we? I can't box it. Why can't I box it?
Oh, because that's not the answer. That's not possible.
It says plug in. Approximate f of 2.3, right? Couldn't we do like a such that?
I don't know if that's allowed.
Plug in your calculator. Who has it for me?
Kyle has it in about 2 minutes.
Yeah, like okay, you put it in. 7.77. Oh.
7.7.
Thank you, Dad.
7. 0. 1. So 2. If you truncate it 1, if you round it 2. Okay. Let's leave extraneous comments extraneous. Okay, so letter B. The fourth derivative of f satisfies the inequality. Ooh. Huh. That's funny. They asked us about the third degree one. Now they're telling us about the fourth derivative. That's a thing. You should know why. Alan.
Just a general question on the AP. If they ever say give 3 decimal places and you find a way to put it in a fraction, would they ever talk for that?
No, because the fraction, if you got it in decimal form, would be equivalent. You should be all right. I mean, to be safer than sorry, I would always just try to give them what they want, but I mean, not within the realm of stick it to the man for sure, as much as possible. Jason.
It's actually 6.99.
Ooh. 6.99 what?
4.
Okay. You can't judge if you're not the one who's helping.
I was doing something crazy. I was making a pig.
Making up cake?
I was making a pig.
Oh. I mean, it's somewhat applied. Okay, so why are they telling us about the fourth derivative of f? Starts with a la and ends with a grange. Why? Lagrange says, look at who? The n plus fourth derivative, right? Okay. Wait, why'd they say the interval 2 to 2.3? I don't get it. Isn't that from C to the number that we're trying to approximate? Okay, so that's exactly what the theorem tells me. Use the Lagrange, oh, they say it. Bound on the approximation of f of 2.3 found in part A to find an interval such that, ooh, all right, cool kids, you go. We've done this 3 times. That was just today. You got it.
I knew this. Oh, yeah. Error equals less.
Error bound. Okay,
Like
f
so,
to the fourth derivative.
Fourth derivative of c over 5 factorial. 4 factorial.
Did you just say 5?
No.
4.
Okay.
Kyle.
Okay.
Two.
Minus 2. There you go.
Kyle.
Equals.
Equals.
Okay,
well, we have to find
so
c.
we need to find C. What, max?
We don't have to find c.
No, it tells you.
It tells you z is 2 is 9.
9. That Z is the
Pause. Z is not 9. Who is?
X of it.
oh,
Max is the max.
F to the max is
Yeah,
9.
max is
So
9.
9 over 4 factorial. times 0.3 to the 4th. Buffett. No?
Give 3 decimal
find an
places is less than.
You find it in the book.
It's the answer.
It's not a book problem.
0.003.
Minus
0.003.
I can
3 decimal places.
But don't you need to plug in 6.9?
Minus 0.00. Oh, 3037.
I was lazy. You can be lazy on an FRQ too, right?
It's negative 6.994 plus.
Gracias. But pause. The L, does it make sense? Okay. Now hold on. I was trying to shortcut the math. What was I shortcutting?
Oh, just right here.
F of 2.3. How do we find error?
F of F minus B.
Minus the approximation. So how do I solve for the F? Add. I was right. Add. F of 2.3 minus P sub 3 of 2.3, right? So if you want to, you could go ahead and write that. You could say F of 2.3 minus P3 of 2.3 is going to be less than or equal to L, right? Because check it, isn't P sub... I did. He's positive. He's added. That guy was a positive. He's added. That guy was a negative.
So why is the difference?
Because the absolute value, remember, we say that the error could be above, that's the positive, or below the negative. Nope. Nope. Look. Look, this is 6.994, right? P sub 3 of 2.3? Yes. So then when I set them up, it'd be F of 2.3. I have a negative L on one side. I have a positive L on the other side. Take out the absolute, no. Take out the absolute value between negative and positive, showing the below and above. Then add. Does that make sense? There you go. That's random and it's an aside. Looks kind of like upside down Oklahoma. Anyway, so. Right. So, F of 2.3, who has a decimal for me?
Oh, 6.997.
On the upper bound? What's the lower bound?
6.991.
Someone back him up.
Someone prove me wrong.
Wait.
He's right.
Well, like, the decimal A is technically wrong.
Still not 6.994.
It's technically wrong, but it's
Wait, why? It's on the basis of how many times are we going to change it?
You guys are the ones that aren't helping and supporting and making sure he's right. Pause. Now we're good?
yes.
Okay, which means? Not everything. Not everything. If I have time, you have time.
Oh, it's 2-1? Yeah, it's 2-1.
I think yes. It's 0.003. Yeah, 6.924. Yeah, it is an integral. I heard 6.991.
Because it was 0.3 or 0.4? Oh, okay. Long story short, don't complain unless you try the math. Okay, so, whoo, yes or no?
Still yes, actually. Yes.
Yes.
No, it's no.
Are you guys sure that you were wrong? You were wrong, for sure. Okay.
Wait, no, it's. Oh, wait, no, it's not.
No. Can't read.
Kyle can't read. Kyle says 5 when he
Who jinxed it? I'm proud of you. You did your best.
Guys, guess what?
Especially on the 18th.
We're done. Have the whole homework attempted for tomorrow. Come with questions. Bye.
It doesn't matter.